Daniel is a software engineer at, he's a manager with over 20 years of experience working on enterprise softwares in various roles. He is currently engineering manager and has an open source distributed storage software team for the software. His background, however, is in large scale distributed software with 9 years working on Grid Engine and 3 years working on Apache Hadoop, Yarn, and his passion is building large scale distributed software and helping to develop engineers to reach their full potential. So now that I have butchered that, I will let Daniel do a better job of explaining to you his role at Twitter and some of the work that he's doing with big data. And then I believe that he has a member of the university recruiting team from Twitter who will join us to talk about some of the opportunities that are available for Twitter, internships, as well as full-time roles.
Absolutely, yeah, thank you. All right, so yeah, we'll get into this. This should not be a terribly long talk. I'm betting it's about 25 minutes, so we'll have lots of time for Q&A afterwards, hopefully. If there are questions, it's probably, given the remote format, it's probably easier to wait to the end and you can hit them. If there's a chat channel, you can also feel free to drop questions in chat. So Kelly is here from the university recruiting team. You recognize us because we're wearing our blue Twitter shirts. So she'll be here to help you with program questions if you want to know, how any of that works. And I'm here for technical stuff. So let's just hit this. So what we're going to talk about today is big data. And let me tell you, what I'm going to talk about is just going to blow your mind so much. It's going to be so tweet worthy. You're going to want to live tweet this. If you do, the hashtag to use is VandyTweetUp20. And we'll see what we generate out of this. All right. So, let's see, let me press in the right place. There we go. So, yep, that's me. My pronouns are he and him. If you want to find me on Twitter, you can find me at TempleDF. And in general, on all things, I am TempleDF. I am the only person who ever uses that username. And I know if I go to create an account and that username is taken, I already have an account. And I got that username from Vanderbilt. That was the username that was given to me my undergrad year. So I've been using that ever since. All right, so here's my plan. Really brief bio, then we're going to talk about what is big data, define it so that we're all on the same page here, and then we're going to talk about what is it like to work in big data, and why am I still doing this after so many years. And then we'll wrap up with some time to talk about what Twitter has to offer, what the programs look like. All right, so first off, me. So I graduated in '97 with a double major in ECS. My fun fact of that year is I actually had a triple major. It was ECS and computer engineering, but my year was the first year they disallowed that triple major. So I only got a double major. Got a job, went to work for Sun Microsystems, ended up working on this product called Grid Engine. So Grid Engine, which you probably have never heard of, it is old school, massive scale distributed resource manager. It is, if you know about Hadoop, you can think it's very much like Hadoop except minus the data. Back in those days, our data wasn't big. So we really were just worried about compute. And so Grid Engine was kind of the leading open source distributed resource manager of the time, job manager, if you will. So worked on that thing for a freaking long time. I was at Sun so long that when I left, it was Oracle. So I left Oracle because Oracle was a horrible place to work in 2011, and I went to Cloudera, which was a little startup that was doing specifically big data. So open source big data technologies, Hadoop, HBase, Scoop, Flume, Oozie, Pig, Hive, Impala, all these technologies, either Cloudera was invested in or many of them we actually created. So by 2017, I became a committer on the Hadoop project itself. And in 2019, I left Cloudera to join Twitter. And here at Twitter, I am managing a team who handles all of the compute technologies for Twitter. So right now, our focus is on Apache Spark and Google Dataflow, and providing all of the tooling around that and extending those platforms as Twitter needs. So that's me. Let's talk about the more interesting stuff, though. What is big data? So first off, let's kind of level set and let me be clear. When I say big data, what I mean is big data technologies or technologies for processing big data. It's not about, when I say big data, and I'll try in this talk to talk about capital big data or lowercase big data. When I talk about capital big data, what I mean is not the data itself. It's about all those great tools that you use to process that data. So that's often a point of confusion. So let's talk about what is little data big data, or what's the word, lowercase big data, and define what that is so that we can define what does it mean to process it. So lowercase big data is kind of a misnomer. It's not so much about the size of the data. It should really be called inconvenient data. It's data that's just, it doesn't fit your normal data processing standards. And there's a few reasons why that might be the case. And the big obvious one is in the name, because it's big, right? If I need to sort through an exabyte of data to find information, I'm going to be hard pressed to do that with most other technologies. Once you start hitting a certain quantity of data, if you want your query to complete this month, you end up having to reach out to the big data technologies, put it on a big cluster, do some massively parallel computation. But size is not the only reason why your data might be big data or inconvenient data. Another one, and you see this in the junk drawer, is variety. Right? If you have data that is not of any kind of standard format, think log data, for example. It's not a nicely structured tabular format. It's just stuff. That is kind of a poster child for big data. In fact, I often use Spark, which is a big data technology, for just processing simple things like CSVs and TSVs, because while they're structured, they're not structured enough that you can drop them into a database, and they're great for spreadsheets, but spreadsheets have limited capabilities. So a big data technology like Spark gives me a lot of capability of doing what I want with data formats like CSVs that aren't quite exactly the kind of thing that you would normally use in a database. Another reason why your data might be challenging to work with is simply how fast it's coming at you. Right? There's a whole group of big data technologies that are focused on dealing with streaming data that is coming at you really fast. And again, it also ties into the amount of that data, right? Which I guess is also how fast it's coming at you. Up to a certain point, you can use conventional technologies, but then you hit this point where the data is flowing so fast, the only way to keep up is distributed infrastructure, doing these big data technologies. So those we used to call this back in the day, we called those the three V's: volume, variety, and velocity. And then there was a fourth of the third V's, which was value, which we'll talk about a little bit in a second. And then they came up with a fifth V that I don't remember. And anyway, at this point, I think we're pretty clear on what lowercase big data means. So let's talk about uppercase big data. So uppercase big data, what it really amounts to is a bigger hammer with which to tackle lowercase big data. So if you look at these technologies, they are specifically designed to operate at scale. They're specifically designed to deal with data in whatever format you can come up with at massive volumes, potentially going by at high speed. So when I talk about big D data, or a big, God, I cannot say that, uppercase big data, what I'm really talking about is these kind of bigger hammer technologies. So let's talk about value for a second. So this is an anecdote or a story that I stole from someone I used to work with at Cloudera. And he used to tell this story when he was at an industry conference. You all, well, I don't know if you remember conferences, but back a couple of decades ago before COVID, we would actually all gather in one place for a conference and talk to each other in person. It was really weird. When you're in that sort of environment, everybody is remote. Everybody flew in for this conference. And so everybody, if they ate breakfast, lunch, or dinner, or got a coffee or took a taxi, they've got a receipt in their pocket, right? So my friend from Cloudera would say, okay, who here's got a receipt in their pocket? And of course, everybody would raise their hands. And he'd say, okay, so now what is the value of that receipt? You could argue it's zero. You could argue that it's just tiny bit more than zero, maybe. I would actually argue that it's negative because now you've got something you have to deal with. You've got to shred it so that people don't steal your numbers. You've got to dispose of it somehow. It has an environmental footprint. I would actually count the value as slightly negative of owning a receipt. But now imagine that instead of that one receipt that's in your pocket, imagine you have 1 billion receipts. What's the value of that? Suddenly that thing which on its own was worth little to negative is now worth a lot if you get enough of them. Because what you can do is you can take all those receipts and you can construct accurate buying histories of everybody in the area. You can tell when and where people are buying what. You can go back to local merchants and say, hey, did you know that at 10 a.m. there's a rush on bagels in this 4x4 block area? Right. So there's a lot of information, a lot of value that you can get if you can pull together enough of this, what I would call garbage data. And that is really at the core of a lot of kind of the value of big data. Is the idea is we give you an infrastructure where it's cheap and easy to store vast amounts of garbage data, and then give you processing technologies that make it perfectly viable to sift through all that garbage data and actually extract value from it. So that really, I think, is the crux of the story of big data. All right, so one of the things that always comes up when I talk about big data is big data versus data science, right? So let's talk about these two things. So data science, and this is my definition, you all are free to disagree with any of this. Data science is about getting insights out of data using math, right? Doing some kind of clever mathematical analysis on it. Whereas big data, as I'm defining it, capital or uppercase big data, it's about processing inconvenient data. These are two entirely different things, but you can see how they could overlap, right? The more data, so what Google showed very early on as they started getting deep into machine learning was that given two algorithms, one algorithm that might be better, but the other algorithm that has more data, the one with more data is going to win. More data always trumps better algorithms. So why not take that to the extreme and give it all the data, right? Now you're in big data land. And that is exactly where Google lives. It's where a lot of companies live, including Twitter. One of my favorite stories on this, I've been telling this story for over a decade now. Back in, actually, I guess not over a decade, coming up on a decade. Back when I first joined Cloudera, we had a credit card company that was looking to get started using Hadoop. Now, back in those days, this was 2012. So back in 2012, absolutely every big company knew they desperately needed Hadoop, but none of them actually knew what it was or what to do with it. And this company was entirely in that boat. They're like, oh my God, we need Hadoop. Please sell us Hadoop and then tell us what it is and how to use it. And so we said, okay, simmer down there. Let's start with a trial, what we call proof of concept. So we sent in some consultants and had them set up a modest cluster, couple dozen nodes with Hadoop, and try and figure out, okay, so now how do they evaluate, how does this Hadoop cluster compared to the databases that they're using now? So they decided, you know what, let's try this. We do fraud detection on our databases. So we have SQL queries that are effectively data science, although at the time data science wasn't a term, but the data scientists produce these SQL queries which are able to analyze the data in the database and determine which of these transactions are likely to be fraudulent. Hadoop supported and still supports a SQL interface. So they said, all right, let's load up our transaction history into this Hadoop cluster and let's run our fraud detection SQL queries against this cluster and see what happens. So they loaded up as much data as they could fit in the cluster, and they kicked off the fraud detection algorithm, and it returned in record time. And caught the largest case of fraud in the company's history. And the reason that they had never caught it before is because their databases were only capable of dealing with, I think it was 9 months of data at a time. Whereas this Hadoop cluster, because it was designed for scale and for digging through massive amounts of junk data, was able to fit years and years, 5-6 years of data. And so whoever was perpetrating this fraud understood that the window for their fraud detection algorithms was relatively short. And so they just made sure to never do the same thing twice within the given window. But once you lined it up with 6 years worth of data, it was obvious that they were perpetrating this fraud. So that was a huge win for that customer. And I think it does a really good job of illustrating the value that you get out of bringing big data and data science together. All right, so let's talk about big data technologies. Big data technologies fall into two broad camps. There's essentially compute and there's storage. And that is those very, very broad camps. Technologies that you might recognize in this category. So on the compute side, I'm sure at this point you've all heard of Apache Spark and Apache Beam. Those are very popular technologies. Beam is actually just the API for Google Dataflow. Hive is that SQL interface I was talking about back in 2012. Still going strong. So Hive is a SQL interface on top of Hadoop or Spark or Tez, which is yet another compute framework. So there's a bunch of compute technologies. On the storage side, there are fewer because there isn't quite as much need for specialized storage technologies. You might be familiar with Apache HBase, which is a giant, it's actually an open source implementation of Bigtable. So it's a way to store an absolutely enormous database effectively. Cassandra is not dissimilar from HBase. It is it's yet another technology. Now, Avro and Parquet are not about storage. They're about data formats. So Avro is a row-oriented, evolvable schema data format, and Parquet is a column-oriented data format. Now, why do you need data formats? Why does this matter in the big data ecosystem? This is also one of my favorite things to talk about. I love this about it. If you have all your data in Oracle database, the only tool that you can use to access that data is the Oracle database. If you want to pull that data out and go work on it with SPSS or SAS or whatever, you have to go through this long export process to pull it out of the database, move it over to whatever tool you're going to use, do your processing there. Now, in the meantime, the data in the database could have changed. And if you're talking about a huge amount of data, this can become impossible to do, literally impossible to do. If the data is big enough, you're just never going to move it. Now, what the difference with the big data technologies are that if you look at Spark, you look at Hive, you look at Druid, you look at Flink, for that matter, Dataflow and Beam, they're all using the same data sitting in the same place. So you can literally go in, do processing with Spark, produce output back to the storage, then go into Hive, read that output, do something more with it, output that into some Hive table, which you could then pick up with Beam and do further work with. So it's really neat that you have all of these tools at your disposal, and they're sharing a common storage framework. And in order for that to really work well, you want to have common storage formats. So that's why we have common formats like Avro and Parquet, and those are arguably the two that you should care about. There are others, but they are less popular. And then you'll see in the middle here, we have the original Hadoop. So the reason Hadoop is in the middle is because Hadoop is actually composed of 3 separate technologies, MapReduce and Yarn, which are the compute technologies, and then HDFS, which is the storage technology. And the reason why one project has all of that is because back in the day, it was a really cool hack to combine compute and storage into one entity and scale compute as you scaled storage. It was a way to get around network bottlenecks, which we'll talk about that in a minute as well. These days, we don't do that anymore. We've decided it's cooler to separate them, and so we're now back to separation of compute and storage. All right. So let's talk, we've kind of got a good sense now of what is big data and what are the technologies in play and where did this come from. We've got some fun stories about why it's cool. What's it like to actually work in big data? So I've been doing this, I've been working in big data directly since 2011, indirectly since probably 2008. And if you count Grid Engine, it's the same sort of animal, but just without the focus on the data since 2002. So I've been at this for a while, and I'm still at this because I love it. It is really cool. So what is so cool about it? All right. So first off, and this is going to absolutely be self-aggrandizing, but it's just freaking awesome. Big data is the extreme end of computer science. If you look, there's several extreme ends of computer science where you're really, by definition of your day job, pushing the boundaries. But big data absolutely is one of those. If you look at the goal of most big data organizations, it is to push the boundary on what's possible with regard to the amount of data that you can process it, how rapidly you can process it. It's really fun to actually get to apply your computer science skills directly to software engineering. One of the things, if you read Twitter, there's been a lot of chatter about this lately on Twitter. There's a lot of annoyance among the software engineering community that our hiring practices, our interviews, all ask computer science questions. Because if you actually get to the job and you start working in software engineering, you're not doing computer science, right? How much computer science goes into being a full stack web engineer? You gotta know how to program. You're never in your life going to implement a linked list or a sort algorithm or traverse a binary tree or like none of that. None of it. In most of the time in software engineering, you are not doing computer science. You're doing software engineering, which is honestly why some of the best software engineers that I've ever worked with were electrical engineers, not computer scientists. So anyway, big data, what's great about big data is that we're working in that domain where we're pushing kind of the boundaries of what's possible. You have to understand so much of it. And the reason for that is that we are dealing with distributed systems operating at large scale. There is such a massive difference between a 1-node application and a 10-node application, and between 10 nodes and 100 nodes, and 100 nodes and 1,000 nodes, and 1,000 nodes and 10,000 nodes. So in Twitter, we are running clusters, Hadoop clusters that are 10,000 nodes. That's 10,000 workers reporting to a single master, coordinating all of the pipelines that are being executed. That is beyond crazy. Back when I used to work at Cloudera, which was one of the companies that created Hadoop, we would point at Twitter and go, oh my God, the stuff those guys are doing is crazy, right? So you get to operate at scales that are really mind-boggling, and the problems that you face, you're just not going to face in other places. It makes you really, really pay attention to what you're doing. If you're dealing with, I don't know, you're sorting stuff, right? And you've got a sort algorithm that's a millisecond slower than another one on average. As an average developer, you don't give a flying hoot. That does not matter in the least. But when you multiply that times 10,000 servers churning through operations over and over and over again, that millisecond starts adding up and starts making a difference, right? So you end up having to care about details that you might not have ever even noticed before. So it's really awesome. Now, the way this manifests, if you've ever tried to do large-scale distributed systems, if you've ever messed with even modest-scale distributed systems, you'll understand that working in distributed systems, trying to push the boundaries of scale, is really about playing whack-a-mole with bottlenecks, right? You're trying to go from 1 node to 10 nodes. You get the network communication worked out, and you run it, and you realize, oh, darn it, this particular lock, right? I've got locking issues. I was all on one machine before and the locking was right, and now I'm having issues with lock contention because it's distributed. okay, so I fixed the lock. Now it's running well on 10 nodes, and you try to scale to 100, and you realize, oh darn it, the data store that we were using, it was great at 10 nodes, but now at 100 nodes, there's too much pressure on the data store, and so that's my bottleneck. And so you take that single node data store and you make it a cluster itself, and now you're humming at 100 nodes, and you try to go to 1,000 nodes, and you realize, oh crap, okay, so my data store is operating okay, but my network is now saturated. I can't get my data to my nodes fast enough because there's too many nodes contending for the network, and so on and so on and so on. The limit of there's always a limit to your scalability, and working in distributed systems is really a big game of whack-a-mole on finding and removing those bottlenecks. All right, so beyond the general discussion that we just had, let's talk about kind of more specifically what sorts of skills you want to develop or you will develop by being in big data. Number one is concurrency. We are operating in a world where everything is massively multi-threaded, and understanding how to work in a concurrent environment is really critical. When I am interviewing, that is really my proxy for whether somebody is going to be able to be effective working in distributed systems. So you may not know this yet, but you will discover it shortly if you don't. Resumes lie. People put things on their resumes that aren't necessarily true. So you can't necessarily believe everything that's on a resume. And so somebody says, oh yeah, I'm an expert at distributed systems. My first question is, okay, let's talk about concurrency. Here's a concurrent problem. Let's talk about how you would solve it. Because that is really where the rubber meets the road in distributed systems. You also have to understand networking. You have to understand how the networking protocols work. You have to understand the difference between synchronous and asynchronous protocols, and when to use what, and what kind of problems you can create by using one versus the other. And along with that goes security. This is one of the things that people don't typically get. It's not obvious to the casual observer that in distributed systems, security is really, one, it's really important, and it's really, really hard. Getting security right in distributed systems is really challenging. And if you look at a lot of distributed systems, the way they solve this is simply by not having any, right? They're like, you know what, we're not gonna solve this problem, so we're gonna go with what we call security through obscurity. Right, it's kind of like if you think about an easy example is think about any of these console games like your Xbox or your Switch that talks to a central server, right? And you're playing these multiplayer games. There's nothing really guaranteeing that you are who you are and that you haven't messed with things. What guarantees it is that in order to mess with things, you would have to decompile their code and mess with it. And guess what people do? They decompile their code and they mess with it. And so I still have a Wii U and we play Splatoon, and it's getting hard to play Splatoon because this game's old enough now that pretty much everyone is running with a hacked version of it. And so it's not fun anymore because everybody is immortal and yeah, I mean, this happens. So this is kind of built into distributed systems. So solving security is, especially in distributed systems, really hard. Your CS fundamentals actually do come into play. No, we don't implement linked lists or sort algorithms or traverse binary trees very often, but sometimes we do. And more importantly, we need to understand the implications of choosing a Java array list versus a Java linked list for this particular application, because like I said, whereas in a single application, maybe it doesn't matter, a single node application, you're not going to notice so much. When you start scaling that stuff up, it starts to matter big time. And then in addition to that, you also have to understand kind of all the way down to the metal. I'll tell you a fun story. When I first started on Hadoop, one of the first things that I did, I was working on the HDFS on the storage layer at that time. And there was this particular section of code that was focused on verifying that the data was still valid, that there hadn't been a disk error and that something hadn't gone wonky. So it was running through and computing checksums and comparing that to the last known values. And I noticed it was doing it serially. And it was actually one of the big bottlenecks in the system. This thing was running all the frickin' time because it was serial and it was so slow to go through all that data serially. So I thought to myself, well, I'll fix that. And I spent a week ripping out this serial process and replacing it with the most beautiful work queue that was handing things off in a parallel fashion. Oh, it was so gorgeous. And when I finished it up, I went for my code review with a more senior engineer. The first thing that the engineer said was, so you know how disks work, right? Disks read data serially. So you built this really great parallel thing, but what the effect of this is going to be is causing lots of random seeks all over the disk. And your disk is actually your bottleneck. So while you made the software faster, you made the hardware slower, and that's actually going to be a net negative. So how about rip all that out? So it pays to understand everything down to the details, down to the networking details, down to the disk level, the how concurrency is handled, what locking looks like in the kernel, all that stuff. All of that stuff is relevant in distributed systems and big data. All right, now one of the things that is actually surprisingly hardest in distributed systems is debugging. Right. One of the things that you'll pick up as soon as you get out and start doing paid work at a company is unit tests, right? Everything has to have unit tests, make sure it's still working. How do you unit test on 10,000 nodes? Like there are so many issues that you encounter in distributed systems in big data that only show up when you're pushing the boundaries of the system. You can't run unit tests that do that. So how do you make this work? It's actually a really hard problem, and it's not a solved problem. A lot of it is manual effort of figuring out how to convince the system that it has way more nodes and way more workload than it actually does, and try and stress some particular piece of the code. So the debugging aspect of it is really challenging and honestly fun. It is fun to go dig through this stuff. You will, if you have a career in big data, you will become an expert diagnostician, which it's funny. When I go to the vet, I've got a lot of cats, or used to have a dog, or when I go to the doctor and I'm trying to explain what's going on, I have more than once had the vet or the doctor say, wow, you're really good at explaining problems like this. And I'm like, yeah, this is what I do. I am a diagnostician. That is what being in big data is about. It's understanding how to frame a problem and how to dig into the details until you actually capture it. So that's kind of, that is my summary of what it's like working in big data. Let me hand it over to Kelly for just a minute. She's going to tell you a little bit about what Twitter's University Recruiting Program for 2021, I guess also late 2020, is looking like. And then we'll be here to answer questions if you've got any. All right, Kelly, can you manage to unmute?
I can. Can you hear me?
Awesome. Yes.
All right. I feel so much smarter after listening to you. So thank you, Daniel. Okay, I'm going to be honest with you. This is really weird for me, Kev and Fatin. Like I see you on the screen. I'm used to being able to talk to you in person. This is really weird doing this from my bedroom right now. But very happy that you're here joining us today, tonight. And just wanted to answer any of the questions that you have too about like roles at Twitter. I'm on the university recruiting team. So my name is Kelly. I was like, I have my closet right here. So this is my handle. It's home baby. There's 5M. So if you want to, you can follow me if you want to see what life is like at Twitter or just the type of opportunities that we have. But I'm curious, just first, before we go into all the details, I wanted to know what year you are and like what type of opportunities you're looking for, whether it's like an internship or full-time.
I guess I can go first. So
Okay.
I'm a freshman.
Wow, look at you.
Yeah, I'm not that advanced in computer science. I only started learning this summer, like
Yeah.
started learning Python, but it's really interesting. So
Mhm.
probably like what my goal is for this summer is just to get an internship and get a lot of CS experience under my belt, and that's pretty much it. Yeah.
Okay, perfect. And we've got, let's see, anybody else want to, just so that I can answer specific questions. Hi, Brian.
Hey, Kaylee. So I'm Brian. I'm a junior, majoring CS.
Okay.
So my original plan is to find another summer research opportunity in the coming summer. But I know about this talk and I really wanna learn from it. And now I'm also considering probably a internship in the next fall because I can probably graduate early. So
Oh,
yeah.
okay. Okay.
Thanks.
Thank you. Anybody else? You don't have to unmute yourself, but okay. So that's super helpful. So yeah, I'm on the university recruiting team. I represent the HYPE team. We're the team that goes on campus every fall and spring. And one of the big dates just to know is that our application opens actually this Thursday. So we have the link here. You just go to t.co/apply. So we have a lot of anxious students that are waiting to apply, and those are for all internships and also new grad opportunities. So make sure you go there on October 1st. In the previous years, we've had internships throughout the year, but next summer, just because of, like we're all virtual right now, but we will have an internship next summer, but it will be virtual. So there'll be flexibility in where you can work from. You obviously would not need to move to a city where we have a Twitter office. You could work from home. As Daniel mentioned also, he gave you the hashtag. It was the Vandy Tweet Up 20. So whenever we go on campus, we always, we tell students, keep your phones on. The Twitter platform is following these hashtags that we're letting you know about. So definitely just tweet about any either questions or anything that kind of inspired you from Daniel's talk today or anything about Twitter. Use that hashtag. And it'll be from the Twitter U handle. I definitely would recommend following that handle too. And then let's see. So for Kev, since you're a freshman, so that's awesome that you're attending these talks right off the bat. The opportunities that we have for first year students, it's not a full internship, but it's a week-long program that we have called Early Bird. So for those opportunities for first year students, you would just go to t.co/ibelong, and you'll see the opportunities that we have for first year students. Our internships that are the full summer are for our second and third year students. And then on the bottom, you'll see we have a lot of links here. So I don't know if it's easier just to like screenshot this, but t.co/university will show you basically a lot of information about all the different types of programs that we have versus going through every single slide and having you try to remember it. You can look at t.co/university. And then on the very bottom, so when you do apply, hopefully on Thursday, when you apply for any type of internship or new grad position, we have like basically on t.co/teams, this is what you'll see. And it really shows you like how Twitter is organized, like on all of our teams. So, on our build a product side, we have our data science and analytics, we have design and research, infrastructure engineering, machine learning, product and software engineering. So you're able to select up to 3 of these teams here. And I'd highly recommend you select more than one because it's going to give you a lot more visibility. When you apply, there's going to be different teams looking at your background, your experience, projects you've worked on. And so I would recommend picking more than one if there's other, groups that are of interest to you. And let's see, does anybody have any questions so far?
Yeah, let's just roll to the Q&A portion of the program.
Yeah.
There, we're in the Q&A portion of the program officially.
Okay, here we go.
And I should also throw out there, so I have a team of 6 engineers right now. I am hiring for a senior engineer, as well as I'm looking for 2 new grads and an intern for the summer.
Mm-hmm.
So if you're interested in what I'm, to use the terminology that my children like to use, if you're smelling what I'm laying down, then hit me up on Twitter. You've got my Twitter handle at the front of the presentation, TempleDF. hit me up and we'll see what we can connect.
I'm just going to give you on a personal, like Daniel is awesome. So he has traveled with me to hackathons. He does a lot of our events. He is so passionate about all of you, students like you, coming to Twitter, bringing your own ideas. Twitter is a better place because of Daniel. So I would highly recommend wanting to work for his team for sure. But yeah, here to answer any questions.
I have some. I'm sorry, you can go ahead.
No, it's all right. You can go. You.
Okay. So I actually have several questions. The first is the recruitment for international students. So some of my fellow international students apply to several companies. They kind of like what they encountered is that as soon as they submit their application indicating that they're an international student, they got the kind of reject letter. So I don't know whether COVID or these factors are affecting the internship opportunities for international students.
At Twitter, we are hiring students all over the world. We even just this past internship, I mean, it was crazy because we were just, when summer was approaching, we're really hoping that obviously the internship program wasn't going to be canceled, but Twitter, Jack, our leadership, they are so passionate about students and our internship and new grad program that was no doubt that it was going to be, that would keep it. And we had interns they were interning all over the world just this past summer. So it's definitely something that Twitter wants to make work. There's going to be, there's a work from home, and we just have to make sure that we've got Twitter as jurisdiction for you to be able to working in certain places. But yeah, we definitely will be hiring interns and new grads from all over the world.
All right, thank you, Kelly. I actually have another question, but I guess Kev can go first.
Okay. Thanks, Ryan. So like I said before, I'm a freshman, and so you referred to the early bird program.
Mhm.
And if I wanted to get an internship maybe later then, like what should I learn, or like how should I best prepare myself to prepare myself for like that process later on down the road?
Daniel, do you want to, you can give that and I can give my opinion, but go ahead, Daniel.
Sure. Yeah. That's a tough one, right? Getting that first internship, right? Once you got the second one, you get the second one based on the first one. But getting that first one is tricky. So what I'm looking for when I'm looking at resumes, you're obviously not no one. Some folks graduate undergrad, do a couple years of work, and then go to get their master's. So some people actually are coming to an internship with some work experience. But for the most part, if you're looking for an internship, we're not expecting you to have work experience. So what I'm looking for is really evidence of enthusiasm and ownership. I am looking for evidence that you are going to be someone who's going to come in, learn hard, do what's in front of you, and have an impact and really own the problem. So what does that look like on a resume? It can look like a lot of things. I have promoted people to interview, or I brought people into interview because I saw that they had a ton of side projects on their resume. I've brought them in because I saw they were involved in an open source community and were actually making honest contributions. I had one young woman that I brought in for an interview because she was a international chess master. I'm like, okay, that takes some dedication. I'll give her credit for that. So what I'm really looking for are signs that you're really into this and that you're going to be invested in making progress on the internship.
Okay, and just to follow up, sorry, Brian, I'm just gonna take one more question from you. So,
No worries.
when you were talking about the let me look back at the compute and storage, the two categories for the big data technologies. I saw there was like TensorFlow, and so I tried learning TensorFlow, and I wasn't like quite there yet in my like Python journey earlier this summer, so I kind of gave up on it. But when you were going through all those technologies, are those all basically like libraries with tons of like methods and other things like that, or?
On the yes, yeah, more or less, yeah. On the compute side, definitely. On the storage side, less so, but yeah, sort of.
Yeah, okay. That's what I was wondering because for the storage, it was I couldn't picture quite like a library for that kind of like that
Right.
kind of stuff, but okay, that makes
Right.
sense.
Exactly. So I mean, everything's got an API,
Hmm.
but on the storage side, Cassandra, HBase, HDFS, these are giant distributed services. And yeah, there's an API to talk to them, but they're primarily services. But if you look at something like Spark or Flink or Dataflow, it's more of libraries that are being run on an infrastructure as opposed to a service that you're going to talk to.
Hmm. All right, Brian, you
In
can go
fact,
ahead.
so my team at Twitter is called Core Data Libraries because what we deal with is data processing libraries.
Hmm.
All right, I guess I can ask my other questions.
Sure.
So regarding the internship, will Twitter have like internships for spring and fall?
Traditionally, every year we do, but just because of the state that we're in right now, and next summer it'll only be next year it'll only be summer.
Okay.
Hopefully, though, after 2021, like the following years, it'll go back to where we have like
Mm-hmm.
spring, summer, and fall. Yeah.
Right, thanks,
Not
Kelly.
that not that that's in time for you though.
I know. So yeah, I know you had mentioned fall of next year. Unfortunately,
So
not 2021, but yeah.
So you did mention, I'll throw this out because you did mention you're also had the option to graduate early. Um, so I know that we're also looking at new grad hiring is latter half of this year is when it starts. So
Mm-hmm.
we will start hiring new grads at the end of this year.
Right. Thank you. Thank you, Daniel. And actually, I have a, sorry, I have another question.
Mhm.
So, so you mentioned you really expect an intern to be kind of eager to learn and enthusiastic. Are there any kind of specific hard skills that you're looking for? So you mentioned several, like the concurrency,
Right.
etc. So yeah.
Yeah. So that's totally fair. So this is all going to vary depending on what team you're talking to and what kind of work you're looking for. Everybody's got their particular language and their particular libraries that they work with. In my end of the world, if you're talking about big data technologies, the majority of this is Java. In my particular world, it's Scala, which is Java with a French accent. It's still, I mean, you could run, if you understand Java, you'll understand Scala. Um, so when I'm looking at an intern, I'm looking for either ideally Scala, but no one comes out of school knowing Scala unless they're just really over enthusiastic. Java skills and failing at Java skills, even Python or C++ can be valid. I will also, so I should say in my particular team, as I'm looking for an intern, one of the things that we're also considering is big data engineers are really terrible at user interfaces. So we're looking at perhaps even having an intern that is not focused specifically on the big data technologies themselves, but more focused on making them friendly and usable to end users. Because it's a lot easier to get that talent in an intern than it is to try and hire one kind of one-off UI engineer into a team of big data engineers. That doesn't work out quite as well. And as far as like technologies to know, yeah, no, it's kind of, so concurrency, having some demonstration of understanding concurrency is good, and distributed systems even better. But that's a little hard to come by. I don't actually care all that much if you've ever used these technologies. I think it's pretty common these days to see undergrads and grad students come out with Spark as something that they've used. They've done projects where they had to write something in Spark. It's a plus. It means you've seen the APIs. It means you can at least write a little bit of Scala, but it's not that important to me.
All right, Daniel, thanks for that. Just one very funny thing. So a few days ago, like applied for a club that requires a coding challenge. It actually requires us to do kind of Twitter API kind of to get tweets from Elon Musk and Kanye West. So it's really fun. Yeah, just want to mention that.
Wow. Wait,
Yeah,
a club?
I'm sorry.
You were applying for?
Yeah, a club on campus.
Wow.
So basically, kind of ask to build an interface to let the users guess whose tweet is that. So it's really fun. Yeah.
That's interesting. Yeah, Twitter is the API that fuels many a grad degree. There's a lot of research done on the Twitter API.
Mm-hmm.
Yeah. All right. Thanks so much.
Can I take a question?
Absolutely.
Hi, Daniel and Kelly. I know we spoke a lot about software engineering. Can you guys please shed some light on how product works at Twitter and how you work with product managers and what does the recruiting look like for product?
Okay, Kelly, you want to start with the APM, and then I can talk about how does product work with engineering?
Yeah. Yeah. So as Daniel mentioned, we have a program. It's our associate product manager internships. And it's a very, very highly sought after program, very, very popular at Twitter. And for that program too, you don't have to have a certain background to be eligible or to qualify for those roles. We just want you to be able to, you have to have a good understanding. You have to, obviously work well with a lot of our teams. Is that kind of something that you'd be interested in?
Yes. Yes.
Okay. Yeah. So that also will, the application for the APM program will open on Thursday also. So definitely just keep your eye out for that. I can, let's see, when Daniel's explaining, I'll see if I can type into the chat where we have more information about it too.
Thank you.
Okay, cool. Yeah. So and APM, this is not my space, but I believe we also that APM is a new grad program, right? And it covers your first 2 years, so it's kind of a catapult to get you started in product management, because product management is one of those arenas where it's kind of hard to come in as someone with no experience and start telling engineers what your vision for what they should be doing is. That can be a little bit challenging. So it's a 2-year program that you spend your first 2 years at Twitter basically in an intense product management training, and then head off to go be a PM with the team. So the way we work with PMs is pretty typical, really. We've got, so my customers at Twitter are all at Twitter, right? So my customers are all internal, and we have product managers that we work with that are helping to determine, one, what is it that our internal users need? And then what is it that we can do to solve those problems, and helping us kind of narrow down the options and work on timelines and so forth. It's a little different internally. So I've spent my entire career prior to Twitter at vendors, where we actually had firm product releases. Right? Like if you didn't get your code in by the end of the release train, it was not going to ship with the 3.0 release, and customers weren't going to have it, period. Right? Whereas internally, there's a lot more flexibility. Right? We're running internal services, and we're running, keeping internal libraries together. So you can kind of push it pretty much any time. And your customers also tend to cut you a lot more slack than someone who's paying you money. So it's a little bit more relaxed than life at a vendor. But it's still largely the same sort of process. And if you're familiar with Google's APM program or Facebook's APM program, my understanding is that Twitter's is pretty similar.
Yeah, Daniel, I totally misspoke. I was talking about our PM internship, not the APM. The APM is a 2-year program. I put it in the chat if you want to kind of read more about it.
And then we do, yeah, as Kelly was mentioning, we do also do internships for PMs.
Mm-hmm. Yep.
Thank you.
And yeah, and as Kelly said on her slide, all this stuff opens up on October 1st. So if you follow Twitter, you will get the notice when when it updates. Right now, if you go out to our web pages, they tell you about how the 2020 program is going to be. And well, we're kind of past that.
So Kelly, sorry to make you go back to
No, it's fine.
to the early bird, but like what exactly is it? I remember you said it was like a 1 week like experience. Like what do you exactly learn? Like what do you do?
Yeah, so I mean, this year again will be virtual, but in the past, like we fly in students from all over. They come to our San Francisco headquarters for the week. You get to interface with different members of the Twitter like leadership team. In many, like I've been at Twitter for almost 5 years now, and for a few of the different early bird programs, Jack has actually come in to listen to the final projects, because every team basically you're put into teams. You get a challenge, and then on the last day you'll be able to present it to a lot of the Twitter leadership. And so Jack came in and listened to some of the presentations, liked some of the ideas, and said, okay, like I think we could do something like this. And it's just cool because it's coming from our first year students. So it gives you a really good glimpse into like kind of what life is like at Twitter. You get to meet a lot of the different senior folks and leaders at Twitter. You get hands-on, you get to actually create your own projects, and then it culminates with the presentations at the end.
And to be clear, Jack is Jack Dorsey, our CEO.
Oh, yes, yes.
Okay. I was searching it up because I didn't want to sound dumb asking.
Yeah. We're so used to Jack that we don't even think twice about it. Everybody knows Jack.
And Daniel, a small follow-up to what you talked about. I think over the years you worked with a lot of product managers. What is the one skill that you think a great product manager had working with you, or working with an engineer from your perspective?
So there's more than one skill. So product managers, just like any kind of manager, really have a couple of different avenues that they can follow and be wildly successful. So there are those that really understand the technology really well. So my product manager at Cloudera was pretty good about this. Like we would sit down on a weekly basis, look at the projects, talk about progress, talk about the challenge involved, and really prioritize things in a way that wouldn't work if he didn't understand things as deeply as he did. He really got the technology. That can be very effective. You can also be very effective by having excellent vision, being able to predict where the market is going and aim in that direction. And then in that case, you're relying on the engineering manager to fill in all the blanks, and you're kind of trusting that their technical perspective makes sense. You can also, I had a third angle to product management in mind. So a third angle that I see, and I see it actually a lot at Twitter, is down the kind of the project management side of product management. So what they're really good at is making sure that the projects deliver. So following through, keeping things flowing, keeping up with milestones. It smells a little bit more like project management, but it's not quite in that completely hands-off realm of project management. Because project management, a project manager, their job is to make sure the JIRAs, the work tickets, get closed, and they don't really understand anything that underlies it. Their job is just to make sure that people are doing what they're told to do. Whereas a product manager that's more down that project management track has a greater perspective on where things are going, and they know what things are important to get pushed through. And they can help the engineering manager make sure that stuff happens. So I think any of those three is a perfectly valid way to be a product manager, and everybody kind of settles into the roles that are appropriate for them.
Thank you. Really appreciate it.
And I guess I haven't said this yet, which is surprising. So let me wrap up with this, I guess, since it's 5:01 here, so I guess 7:01 there. We're officially done, so let me close with this, which is to say that I'm more than 20 years in the industry now. I have been doing this a long freaking time, and I have never worked anywhere like Twitter. Twitter is so unique. It is such an incredibly fabulous place to work. I just, in fact, if you go look at my timeline on Twitter, I just tweeted earlier today, never have I worked somewhere where the regular company events and all hands bring me to tears.
I saw that. I was
But
wondering about that.
it happens all the time at Twitter, because the stuff that the amount of caring that there is in this company, the amount of sincerity that we have for our mission, which our mission is to serve the public conversation, to make the world a better place through communication. The amount of sincerity that's behind that mission is stunning, and Twitter really is unlike anywhere else I have ever been. It is a really fabulous place to be.
Actually, can I add to that too?
Yes, please.
All right. I'm just going to speak on kind of a personal account, is that at Twitter, so not only am I on university recruiting, but I'm also a lead for one of our employee groups called Twitter Asians. And so we have these groups at Twitter, they're called like business resource groups, same as like employee resource groups. And there's some companies that talk about how they really, all they want is, diversity, but I want to go to a company and I want to feel it and I want to see it. And that is something that I have never experienced like I have at Twitter. And I've been a lead for Twitter Asians for the past actually 3 years. And I have learned, but I'm also like in all of our other BRGs too and allies to them. And so I've learned so much about my fellow coworkers, about culture, about celebrations, about I think I've grown a lot as a person in addition to just, within university recruiting. And so that part alone, the diversity and the celebration and community that I feel at Twitter is something that I haven't felt anywhere else. And so, yeah, if you want to, I always will pop our Twitter Asians handle too. So that's a big part of the reason why I'm at Twitter also.
Well, thank you guys so much. I know that, as I mentioned, that this will go on Doorways for students to watch after the fact. So I feel like you're probably going to get a ramp up of tweets in the next 24 hours. But guys, thank you so much for taking the time to come and speak and present. It was really, really great. And I look forward to pointing students in your direction.
Thanks for having us.
Thanks
Awesome.
so much. I'll talk to you guys later.
Thanks,
All right,
everybody.
stay
Thank you
safe.
so much.
Okay.
Thank you.
Bye. Thank you.